How do we find the cube root of 11? In other words, what number cubed gives us 11? I don't know about you, but I can't think of any integer whose cube is 11. Let's see. 2 cubed is 8, and 3 cubed is 27, so those aren't right. But can I use that to get an idea of what the cube root of 11 is? Yes. In this video, we'll learn how to estimate cube roots. Before we start, remember that a perfect cube is any number that's equal to an integer multiplied by itself 3 times. For example, 27 is a perfect cube, as 3 cubed is equal to 27. Also, taking the cube root is the inverse of cubing. So since 27 equals 3 cubed, the cube root of 27 is 3. Going back to our problem at the beginning, we know that 11 is not a perfect cube, since no integer cubed will give us 11. So, let's find out what two integers the cube root of 11 is between. We do know the two closest perfect cubes to 11. They're 8 and 27. This gives us the inequality 8 is less than 11, which is less than 27. If we take the cube root of each part of this inequality, the resulting statement must also be true. The cube root of 8 is less than the cube root of 11, and the cube root of 11 is less than the cube root of 27. But since 8 and 27 are perfect cubes, we know what their cube roots are. The cube root of 8 is 2, and the cube root of 27 is 3. This means that whatever the cube root of 11 is, it must be between 2 and 3. Okay, now I need to figure out what integer is closest to the cube root of 11. Well, I can use what I just found out, that the cube root of 11 is between 2 and 3. So now I just need to ask myself, is the cube root of 11 closer to 2 or to 3? We know it's between them, but knowing which it's closer to gives us an even better idea of where the actual value is. So let's look back at that first inequality. 8 is less than 11 is less than 27. 11 is much closer to 8 than 27, so we would expect that when we take the cube root, that will stay true. The cube root of 11 will be closer to 2 than 3. And so 2 is the closest integer to the cube root of 11. You can check this with your calculator. The cube root of 11 is about 2.22, which means that both of our estimates were in the right area. 2.22 is between 2 and 3, and is closer to 2 than to 3. Let's try some more examples together. I want to know what two integers the cube root of 82 is between. To estimate cube roots, it's really helpful to know some numbers and their cubes. For now, I've put up a chart of the first 10 perfect cubes for reference. We can find the two perfect cubes that 82 is between, 64 and 125. So, since 82 is between 64 and 125, the cube root of 82 must be between the cube root of 64 and the cube root of 125. Since 64 and 125 are perfect cubes, we can then say that the cube root of 82 is between 4 and 5. For our next example, we want to know which two integers the cube root of 400 is between and which of those integers is closest to. The two perfect cubes closest to 400 are 343 and 512. Since 343 is less than 400 and 400 is less than 512, if we take the cube root of each part of this inequality, we find out that 7 is less than the cube root of 400, which is less than 8. Now we want to know if the cube root of 400 is closer to 7 or to 8. If we figure out which of their cubes 400 is closer to, that'll give us the answer. 400 is 57 away from 343, but it is 112 away from 512. So, 400 is much closer to 343, and the cube root of 400 must be closer to 7 than to 8. How about one more example? We want to find out what integer the cube root of negative 30 is closest to. Remember that unlike perfect squares, perfect cubes can be negative, so we can use the same process as before. Here's a chart of the first 10 negative perfect cubes. For starters, we can see that the two perfect cubes closest to negative 30 are negative 27 and negative 64. Negative 30 is much closer to negative 27 than to negative 64, so we know that the cube root of negative 30 will be closest to the cube root of negative 27, which is negative 3. The cube root of negative 30 is closest to negative 3. Cube roots of numbers that aren't perfect cubes can be hard to calculate, but it really helps to know that you can approximate them. Try it whenever you see cube roots. You'll find that it's more helpful than you might imagine.